Tonight, you're going to dream. Your eyes will move beneath their lids. Your brain will fire in rapid, organized bursts. And for a few hours, you'll experience things that feel completely real. You won't know you're dreaming. You'll just be there. Now, here's what science has recently discovered. The state your brain enters when you dream, the electrical patterns, the surges of activity, the quality of awareness, appears to be nearly identical to what your brain does in the final moments of your life. That's not a metaphor. That's data. Let's start with what dreaming actually is at the level of your brain. When you enter REM sleep, the stage where vivid dreaming happens, your brain produces a very specific type of electrical activity: gamma waves. These are high-frequency oscillations associated with heightened consciousness, memory retrieval, and sensory processing. During REM, your gamma wave activity spikes. Your brain is, in measurable terms, more active during dreaming than during many waking hours. The neurons in your temporal and occipital regions fire in coordinated waves. Your eyes move because your visual cortex is processing images that don't exist. You're not resting, you're running. And that distinction matters more than most people realize. Now go back to second zero. Your heart has stopped. Blood pressure drops immediately to nothing. The 5 liters of blood that were moving through your body a moment ago are completely still. For the first 10 seconds, your brain doesn't know this yet. It keeps firing on residual oxygen. Your neurons are still active. Whatever you are thinking about is still happening. You are still, technically, there. But something is coming. That window is closing faster than you'd think. And what happens next is the part that researchers are still trying to make sense of. Around 10 seconds after cardiac arrest, the cerebral cortex begins to lose power. This is the moment most people lose consciousness. Your eyes stop seeing. Your ears stop registering sound. From the outside, every visible sign points to the same conclusion: you're gone. But in 2023, a neuroscientist named Jimo Borjigin at the University of Michigan published findings that challenged everything researchers assumed about this moment. Her team monitored 4 comatose patients as they were removed from life support. What they expected was a gradual dimming, a slow fade. Instead, in 2 of the 4 patients, the brain did something no one predicted. It surged. Gamma wave activity exploded across the brain within seconds of oxygen loss. Not a flicker. Not background noise. A massive, organized spike concentrated in the temporoparietal occipital junction, a region linked to out-of-body experiences and visual consciousness. Borjigin described the surge as, quote, crazy high. And here's what made it so significant. Those gamma waves were identical in character to the ones your brain produces during REM sleep. The dying brain, in its final moments, was generating the exact same electrical signature as a dreaming brain. What Borjigin's team witnessed suggested something that neuroscientists had largely dismissed. The dying brain doesn't simply power down, it engages. In those final seconds, it synchronizes. The patterns they recorded were not the chaotic firing of a system in collapse. They were organized, coherent, purposeful. The brain appeared to be doing something, initiating something, in response to the crisis of oxygen deprivation. Whether this represents a final neural event or the opening of some altered state of consciousness is precisely what remains unanswered. But the electrical signature was undeniable. And it matched, in nearly every measurable parameter, the precise pattern you generate when you dream. This is where the science meets something much harder to explain. For decades, people who have been brought back from clinical death have described experiences that now have a possible neural mechanism behind them, floating above their own body. Vivid, sensory-rich scenes, a feeling of total clarity. What they described sounds in almost every measurable way like a dream, except they insist it wasn't. And the details they come back with are too specific, too verifiable to simply set aside. And then there's the life review, not the highlights, not the wedding or the promotion or the moment you stood at the top of something beautiful. The small things, a specific afternoon in a kitchen that smells like something you can't quite name, the feeling of a particular jacket on your shoulders when you were 7, a dog you hadn't thought about in 40 years sitting on a step in afternoon light. People who come back from near death consistently describe this. A complete nonlinear playback of ordinary moments they didn't know they'd stored. The detail is the part that's hard to dismiss. One documented case involved a man who described seeing a white cat on a staircase during his life review after resuscitation. He had no memory of the place, no recollection of ever being there. He described the staircase layout, the exact configuration of the building in specific detail. His mother confirmed the family had lived in that exact apartment next to a neighbor who owned a white cat. He was 14 months old when they left. The memory had never been consciously accessible to him. But the dying brain found it, retrieved it, played it back in full. Are all of our memories still in there? Every single one? The kind of total archival access people report during life reviews suggests a system operating at a level far beyond normal waking recall. Neuroscientist Carl Friston has proposed that dying may trigger a kind of memory decompression, where the brain's normal filtering mechanisms break down and you gain access to the full spectrum of encoded experience. If true, this would explain not just the retrieval of lost childhood memories, but the intensity with which they're experienced. Everything stored, suddenly accessible. Everything archived, suddenly present. Dr. Sam Parnia, a resuscitation researcher at New York University, has spent over 2 decades trying to understand what consciousness does during cardiac arrest. His AWARE studies, the largest of their kind, have tracked cardiac arrest survivors across 25 hospitals. The results, published in 2023, are not easy to set aside. Roughly 40% of survivors reported some awareness during the period when they were clinically dead. About 20% described what researchers now call a recalled experience of death. Structured thoughts, clear, organized memories, a coherent sense of being present somewhere. And around 3% reported full visual and auditory awareness while their hearts were not beating and their brains showed no outward signs of activity to the people around them. One of the most consistent elements across those accounts is the sense of not being alone. A deceased parent, a grandparent, someone who felt familiar and calm and purposeful. Some described being told it wasn't their time. Others described being guided, whether that's the dreaming brain generating a familiar presence out of its own archives or something else entirely, is a question no study has been able to settle. But the experience itself is remarkably consistent across different ages, different cultures, different medical circumstances. And what it almost never is frightening. Let's go back to the body. Because while all of this is happening inside the brain, the rest of you is shutting down in a very specific sequence. Around 30 seconds in, your cells begin switching from aerobic respiration to anaerobic respiration. They don't need oxygen for this backup system, but they produce lactic acid. That acid builds quickly. Your muscles relax completely. Your jaw opens. Your eyelids go slack. Around 60 seconds in, the acid has weakened your cell membranes enough that enzymes are beginning to leak out. This is the opening stage of autolysis, self-digestion, your own cellular machinery starting to break down the structures that contain it. It's barely begun at 1 minute. Most of your cells are structurally intact, still whole, still waiting, biologically suspended between what you were and what you're becoming. And your brain, during all of this, appears to be dreaming. Not shutting down the way a machine loses power, not going dark, not fading quietly toward nothing, generating organized gamma activity across regions that process memory and consciousness, and the sense of a self moving through space, producing the exact electrical signature that your brain uses to build the vivid, emotionally charged worlds you visit every night when you close your eyes. The people who come back from the other side don't come back with details of nothing. They come back with specific memories of specific moments. Small rooms, familiar faces, a white cat on a staircase from 40 years ago. The ordinary texture of an ordinary life, playing back in full. Your brain recorded all of it. Every random Tuesday. Every moment you thought no one was paying attention. And in the end, it seems that's exactly what it wants to show you.